All right, here is our first lesson in Chapter 9. We are in Section 9.2, new textbook, etc. So let's just go through. We're always going to have a warm-up and then quite a few examples and then sort of a end of section quiz. So let's just do some math. Let's write this expression in simplest form. So I'm going to do, I think I'm going to actually take that 6 and do 180 divided by 6. That's really messy. So remember, when we have fractions, we multiply across the top and the bottom. So 5 times 180 over 6. Do 180 divided by 6, and that gives me 30. So 5 times 30 is 150 degrees. Simplify this. I've got a new fraction. Let's divide the top and the bottom by 5 just to start out, because I don't know what the greatest common factor is. But the top divided by 5 is 23. The bottom divided by 5 is 36. 23, I don't believe, can be simplified any further. So there is our answer. Okay, I expect you guys to be working along with me in the paper I've provided in your 3-ring binder. You can always pause and rewind if you're confused. We have a few more. Let's see. Multiply across the top and the bottom. I have 11 times 180 degrees over 12. I can't do anything with the 11 and the 12, but let's see if I can divide 180 by 4. I can. So let's divide the top and the bottom by 4. So I have 180 divided by 4 is 45. And then 12 divided by 4 is 3. Can I do 45 divided by 3? I can. Looks like I can simplify this a little bit further. 45 divided by 3 is 15. So 11 times 15 is 165. Okay, it's going to take some muscles from you guys. Let's see. Common. Just did a little bit of math. I'm going to divide the top and the bottom by 45. I think that's going to work. It does. I've got 3 on the top and 4 on the bottom. Okay? All right, last one. A compact disc has a radius of 6 centimeters. Find its circumference to the nearest tenth. Here's your reminder. Circumference is 2 pi r. Go ahead and substitute 6 for r. And we get 37.7 centimeters. Okay, area is pi r squared. So I have pi times 6 squared. The calculator I'm using here at home doesn't have a pi button, so we might be a little bit off. I used 3.14. Tenth, so I want 113 point, I got 0.0 centimeters squared. Yours might be a little bit different. Like I said, I don't have a pi button on my calculator, so I'm just using 3.14. Here's a little vocabulary. Initial side, terminal side, and vertex. I've given you an XY coordinate plane here and an angle in blue. This part of the angle right here is the initial side. Okay, then my angle spans that degree, that distance degree, and I have this part of the angle right here, which is the terminal side. So we begin and we end. And then C is the vertex. Okay, it's where the initial side and the terminal side meet. So standard position is when the vertex is at the origin and its initial side lies on the positive x-axis. Okay, that is standard position. Okay, we have example 1. Let me look really quick. Looks like there are 4 examples, so that just gives you sort of an idea of how to pace this. You may want to take a break halfway through. Generally, I will be able to keep your attention for about 10 or 15 minutes at a time, and I don't know how long the video is actually going to be, so we're going to have to be patient with each other as we do this. All right, so first I have draw an angle with a given measure in standard position. A lot of vocabulary words here. I have standard position, which is different. Let me see, I have a highlighter. I'm going to get yellow. Draw an angle, so standard position. Oof, that was awful. Sorry, still, let's see. It's really dark. Standard position. Standard position means I start from the x-axis, the positive x-axis, and I go counterclockwise, which is CCW, counterclockwise. To figure out 240, I know that a straight line is 180 degrees. So I'm going to do that subtraction right there because I don't know how far to go past. I've got 60 degrees left over. So if I look at my coordinate plane, get all this stuff out of here, I know that this straight line is 180 degrees, and we know that we want to go 60 degrees past that. So an angle with a given measure in standard position means this is my angle, but it's this part of the angle. Okay, that is my answer, not that part of the angle. Okay, this part of the angle is actually, I can say 180 minus 60. That little angle is 120 degrees, not what we're looking for. Draw an angle with a given measure in standard position. 500 is pretty big. I know an entire circle is 360 degrees. So let's see what past a circle is going to be. So I have 140 degrees. So really I'm going an entire circle and then 140 more. Okay, that's really stinky. So 360 degrees and then 140 degrees more. So my angle is actually this one. Okay, that's your angle with a given measure in standard position. Okay, last one. Now we're going negative. Negative means we go clockwise, not counterclockwise, clockwise. I know it's backwards, but negative, we definitely go clockwise. And we just go clockwise 50 degrees. Okay, so this right here is my angle. Okay, our next vocabulary word is coterminal. 2 angles are coterminal when their terminal sides coincide. Okay, the terminal side is the ending side. An angle coterminal with a given angle can be found by adding or subtracting multiples of 360. Let's try. So find one positive angle and one negative angle that are coterminal with negative 45 and 395. So if I look at negative 495, I'm going to add a multiple of 360. And here I actually get 315 degrees. So if I look here, negative 45, I'm going to negative 45 and I'm going to add 360. That's hard to read, isn't it? I didn't add either, I went the wrong way. So let's try that again. So I've got, it said it was with the terminal angle, so I'm negative 45, and then I'm actually going to add 360. So when I add 360, I get 315. So positive 315 and negative 45 are coterminal because they each have the same terminal side, right? Let's try again. So I just did, I added 360. I can also, subtract 360. And that math is negative 405. So when I look at it, I'm at negative 45, and I'm going to add 360. So negative 45 and negative 360. I'm going to subtract 360, I'm sorry. Negative 45 and negative 360 gives me negative 405. So this angle and this angle are coterminal with each other. They actually are the same angle, just different direction and different numbers, but the same measurement. Okay, B was, what was it, 395? Yep, so 395. So find coterminal angles with 395. We said earlier, when I gave you the definition for coterminal, their terminal sides coincide. An angle coterminal with a given angle can be found by adding or subtracting multiples of 360. So let's go ahead and subtract 360. And I get 35 degrees. So 395 and 35 are coterminal. So let's follow along. 395, if I start here, and I go all the way around, that's 395. And if I subtract 360, I get 35. So yellow and blue are coterminal. Okay? I'm going to erase that so that I can do the next one. So I just subtracted 360. Let's try a different way. So I'm going to start with 395. And I'm actually going to, this time let's try 2 times 360. I'm going to subtract 360 twice. So 395 minus 360 minus 360. I get negative 325. So let's look at it. Our first one was 395. So from here to there is 395. Now I'm going to subtract 360 twice and do negative 325. So here is negative 325. I get the same angle. It's a lot of yellow, I'm sorry. All right, so here's a few for you to try. Now with a guided practice, what I would prefer is that you push pause and try these on your own, and then push play and see my answer. So this is where you're trying it on your own, and you're just seeing if you get the right answer or not. Okay, so go ahead and push pause. All right, that's what I tried. Okay, you may not have done exactly the same, but let's look at each other's work and make sure we understand. Okay, try these. Go ahead and push pause, and I'm going to work them on my own, and then push play, and you'll see your answer, my answer, which should match your answer. All right, go ahead and push pause again and check out some answers. This is a great time for you to get clarification from me if you don't understand what I did, or learn from what you see, but this can't be passive learning. This needs to be you in charge and getting clarification if you need help. Okay, we're moving on into radians. So I have a circle on a coordinate plane with a radius of r. 1 radian is the measure of an angle in standard position whose terminal side intercepts an arc of length r. So that means I've got 1 radian, which is the measure of an angle of a circle with radius r, where this angle intercepts an arc with the measure of r. Okay, so the distance here is equal to the distance here. That's important. The other thing that's important is right here. A full circle measures 2 pi radians. How do I convert between degrees and radians? So if I have a certain amount, a certain measurement degrees, I need to multiply it by pi radians over 180. If I have a certain amount of radians measured, I'm going to multiply that by 180 over pi radians. What's interesting is this is radians and this is radians, so the radians are going to cancel out and you're left with degrees. Okay, this is degrees and this is degrees, so the degrees cancel out and you're left with radians. Pi radians to be exact. Let's try a few. All right, convert 125 degrees to radians and negative pi over 12 radians to degrees. So like I said, when I'm in degrees, I want degrees on the bottom and 2 pi radians on top. Scratch that. Just pi. So the degrees essentially cancel out. So what we're going to do is simplify. I've got 125 pi over 180. What can I divide that by? 15? No. Okay, hold on. Okay, let's divide the top and the bottom by 5 and see where that gets us. 125 divided by 5, 25 pi over 180, 36. So that is radians. Now with this next one, I'm in radians. I know that because there's a pi in the problem. And I'm going to convert that into degrees. So I want the pi on the bottom because I want those to cancel out, and 180 degrees on top. Now I multiply across the top and the bottom. The pi's cancel, and I have negative 180 over 12. I think I divide those by 4. My first guess, at least. No. Let's just try 12. Oh, it works. I get negative 15 degrees. All right, your guided practice. So again, I need you to try these all on your own and check your answers. Okay? I'm going to push pause. You're going to push pause also. All right, I did not show my work, so if you're not sure how I got my answer, I need you to ask me. Okay, last example. There's actually more slides than just this last example, but this is the last example. Okay, a softball field forms a sector with the dimensions shown. Find the length of the outfield fence and the area of the field. Now we defined radians as this actually equals this. Okay, but we're not sure what's going on quite yet, so let's try to figure it out. So first we're going to convert this degrees into radians. So I have 90 degrees equals, or multiply by, times pi over 180. That simplifies to pi over 2 radians. Now we want to find the arc length and the area of the sector. All right, so this arc length. All right, step 2, find the arc length and the area of the sector. So first of all, arc length. That's a skill that you may not have learned in a previous course, so I need you to write this down. Arc length is S, which is your radius times theta. This right here is what we just found, which is your radians. Okay, that's in the previous slide that we converted the measure of the central angle to radians. Okay, so that's what we found right there. So we know that for this particular problem, our radius is 180 and theta is pi over 2. So when we do that math, we get about 90 pi, which equals about 283 feet. So I need you to remember that, right? Now let's do area. We do know the area of a circle is pi r squared, but since we have just the area of the sector, it's a little bit different. And this is what we would have learned with circles in geometry class, if you got that far in geometry. I'm not sure if you did, so we'll have to write this down. I have area equals 1/2 r squared theta. And this is, again, the angle measurement in radians. So we know we have 1/2, 180 squared times pi over 2. And that gives us about 25,400 feet squared. Cool? So the length of the outfield is the length of that arc, about 283 feet. And the area of the field is about 25,400 feet squared. Okay, guided practice, this is yours. What if, in example 4, estimate the length of the outfield fence. So the length of the outfield fence. And the area of the field if the outfield fence is 220 feet from home plate. So if this is 220 feet. So what is that and this? Okay, push pause and try it, please. All right, I have arc length, S equals r theta, and there's my answer. Again, pi, I'm using 3.14 because I don't have the button. So your answer may be about 346 feet. And then the area of the sector, I got 38,000 feet, 37,994 to be exact. I just checked the book and they got 38,013 square feet. So if you used a pi button, you may be more accurate. All right, this right here is where we just double check that you understand. Okay, so I'm going to give you the answers. It's also a double check that you understand and don't need any more help. So if you get something wrong, you don't know why, you need to ask, and I'll help you. Okay, push pause. There you go. One more page. Push and pause. All right, there you go. Last one. Good work.